So in the last class, we learned that the molar refraction of a substance can be calculated theoretically just by looking into the molecular structure. Okay, within the molecule, each atom will have its own contribution towards the molar refraction called atomic refraction, and bonds will also have their contributions to molar refractions called bond refractions. ഈ അറ്റോമിക് റിഫ്രാക്ഷൻസും ബോണ്ട് റിഫ്രാക്ഷൻസും കൂടി നമ്മൾ സമപ്പ് ചെയ്യുമ്പോൾ നമുക്ക് എന്ത് കിട്ടും? ആ മോളിക്യൂളിൻ്റെ അല്ലെങ്കിൽ ആ സബ്സ്റ്റൻസിൻ്റെ മോളാർ റിഫ്രാക്ഷൻ നമുക്ക് കിട്ടും. കൂടാതെ നമ്മൾ അതിൻ്റെ 3 മെമ്പേർഡ് റിങ്, 4 മെമ്പേർഡ് റിങ്, 6 മെമ്പേർഡ് റിങ് ഇതുപോലുള്ള റിംഗ് സ്ട്രക്ചർ കൂടി കൺസിഡർ ചെയ്തു. കഴിഞ്ഞ ക്ലാസ്സിൽ നമ്മൾ അസറ്റിക് ആസിഡിൻ്റെയും ബെൻസീൻ്റെയും മോളാർ റിഫ്രാക്ഷൻ ഇതേ രീതിയിൽ നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്തത് നിങ്ങൾക്ക് ഓർമ്മയുണ്ടായിരിക്കും. ആ രണ്ട് കേസുകളിലും അസറ്റിക് ആസിഡിൻ്റെയും ബെൻസീൻ്റെയും കേസിൽ നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്ത മോളാർ റിഫ്രാക്ഷൻസ് എന്ന് പറയുന്നത് ഇറ്റ് വാസ് ക്ലോസ് ടു ദ എക്സ്പെരിമെൻ്റൽ വാല്യൂ. പക്ഷെ ചില സമയങ്ങളിൽ ഇതുപോലെ ആയിരിക്കത്തില്ല. ദ കാൽക്കുലേറ്റഡ് വാല്യൂ മേ നോട്ട് ബി ക്ലോസ് ടു ദ എക്സ്പെരിമെൻ്റൽ വാല്യൂ. ഐ വിൽ ടെൽ യു ഇൻ വിച്ച് സർക്കംസ്റ്റൻസ് യു ആർ നോട്ട് ഗോയിങ് ടു സീ ദാറ്റ് ദർ ഈസ് an agreement between the calculated value and the experimental value. For example, if you are considering an open chain molecule, okay, open chain molecule, you are considering an open chain molecule, open chain molecule, open chain molecule, and if this open chain molecule has conjugated double bonds, conjugated double bonds, conjugated double bonds, and if these two situations comes together, then you may not get an agreement between the calculated value of molar refraction and the experimental value of molar refraction. അപ്പോൾ നിങ്ങൾ മുകളിൽ കൊടുത്തിരിക്കുന്ന ടേബിൾ ഉപയോഗിച്ചുകൊണ്ട് മോളാർ റിഫ്രാക്ഷൻ നിങ്ങൾ കണക്കാക്കി നോക്കുന്നു. അതിനുശേഷം നിങ്ങൾ എക്സ്പെരിമെൻ്റൽ വാല്യൂമായിട്ട് തട്ടിച്ച് നോക്കുമ്പോൾ ഈ കേസുകളിൽ ഓപ്പൺ ചെയിൻ മോളിക്യൂൾസ് വിത്ത് കോൺജുഗേറ്റഡ് ഡബിൾ ബോൺസ് ഉള്ള കേസുകളിൽ അഗ്രിമെൻ്റ് കാണത്തില്ല. യൂഷ്വലി ദീസ് എക്സ്പെരിമെൻ്റൽ വാല്യൂ വിൽ ബി ഗ്രേറ്റർ ദാൻ the calculated value. Means Rm experimental will be greater than the Rm calculated. Okay, so for open chain molecules with the conjugated double bonds, and the observed Rm value or observed molar refraction values will be greater than the calculated molar refraction value. The observed value or experimental value will be greater than the calculated molar refraction value. Okay, or in other words, the molar refraction is exalted. Molar refraction is exalted or raised. Okay, raised. Molar refraction is exalted or raised because of the presence of the conjugated double bonds, and this phenomenon is called optical exaltation. Optical exaltation. Optical exaltation. So this is an important term, optical exaltation. You know what is optical exaltation? I will repeat once again. For open chain molecules with the conjugated double bonds, the experimental value of the molar refraction may be greater than or will be greater than the calculated value of the molar refraction. Or in other words, the molar refraction is said to be exalted or raised by the presence of the conjugated double bonds, and this phenomenon is called the optical exaltation. Okay, optical exaltation. Let us calculate the molar refraction of hexatriene. Hexatriene. This is an open chain compound with conjugated double bonds. Hexatriene, and the structure is like CH2, double bond CH, single bond CH, double bond CH. Okay, then single bond CH, double bond CH2. How many carbon atoms are there? 1, 2, 3, 4, 5, 6, and 3 double bonds are there. 1, 2, and 3, and these 3 double bonds are separated by the single bonds, or you can say that these 3 double bonds are in conjugation. Okay, so this is a perfect example for an open chain compound with the conjugated double bonds. And we learned that in this type of molecules, the observed molar refraction will be greater than the calculated molar refraction. So Rm observed or experimental will be greater than the calculated Rm value. And I will give you the observed value or experimental value in this case. In this case, the observed value is 30.58 centimeter cube per mole. Okay, this is the Rm value or molar refraction value that we found out experimentally for this particular substance. And now we can calculate. Now we can calculate the molar refraction from our table. Okay, so we know that there are 6 carbon atoms here, so let us calculate it. 6 carbon atoms, and also how many hydrogen atoms are there? 2 and 2 4, then 4 are here, so totally 8 hydrogen atoms are there. 8 hydrogens, and 3 double bonds are also there, right? So 3 carbon carbon double bond, CC double bond. So there will be contribution from this atomic refractions and bond refractions. So let us calculate the atomic refractions. And for the carbon atom, 6 into our table shows the contribution of carbon atom contribution is 2.418. 2.418. 6 into 2.418, and hydrogen atoms contribution is 1.1, right? Hydrogen atoms contribution is 1.1. So let us write 8 into 1.1, and carbon carbon double bonds contribution, C double bond C contribution, C double bond C contribution 1.733. 1.733. So that is 3 into 1.733. Okay, these are the atomic contributions and this is a bond contribution. So let us calculate this. That is equal to 6 into 2.418. 6 into 6 into 2.418, that is equal to 14.508. 14.508, and this is equal to 8.8, and this is equal to 3 into 1.733. 3 into 3 into 1.733. 1.733, that is equal to 5.1999. 5.1999. Okay, so these are the contributions, and now we can add this. So when we are adding this, what will be the sum of all this? Sorry, sum of all this, and that is equal to 5.1999 plus 8.8, 8.8 plus 14.508. 14.508, that is equal to 28.5079. 28.5079. Okay, that is the observed value. Rm observed, no, calculated value. Calculated is equal to 28.5079 centimeter cube mole raised to -1. So what was the experimental value? This was 30.58. What is the calculated value? 28.5079. Okay, so we can obviously see that there is an optical exaltation, means the experimental value is 30.58 and the calculated value is 20.5079, and then there is a clear difference, and the difference is or optical exaltation is equal to REM experimental minus REM calculated, that is equal to 30.58 minus 28.5079, and that is equal to, let me calculate it, 30.58. 30.58 minus 28.5079, 5079, that is equal to 2.0721. 2.0721. That is a significant value, right? That is 2.0721 centimeter cube mole raised to minus 1. This is a significant value. It means there is an optical exaltation, and that is equal to 2.0721. Okay, or the experimental value of the molar refraction is found to be greater by an amount of 2.0721 centimeter cube mole raised to minus 1 than the calculated value, and this is called optical exaltation. I hope you all understood the concept of optical exaltation, and if you have any doubt, please don't hesitate to ask me. Thank you for watching and stay tuned.